Alright, so recently I was working on this BLDC controller project, and after doing some googling I found this video on YouTube. And in this video, which was done by AfroESC 2008 Focus, which was done by AfroESC 2008, where he shows that he replicated this application node 857 by Microchip, and I also replicated this. I go to the source website and I downloaded all of the source code and the schematic and stuff, and I tried to replicate it using the actual chip itself. This is the 877 chip, and sadly enough it doesn't work. I'm not too sure how he managed to get it to work, but my circuit doesn't give enough torque, and even if it started, it would just stop straight away even with a very light load. So basically, in other words, I am unable to replicate this application node which was done by Microchip. And because of that, I continue on googling, and then soon after a few hours of googling, I found this BlueESC project. And the good thing about this BlueESC is that well, they have a very good documentation, and after reading it a bit further, I also found their GitHub page, which is good. This is their GitHub page. And then among the files are actually the schematic diagram. So this is the schematic of the BlueESC, and I tried to replicate it, and I download the firmware from here somewhere. The firmware is somewhere in the website, and I put it into the chip. So basically, the circuit on the breadboard that you see here is the same exact circuit that was from BlueESC repo. And I managed to get it to work. But the problem with this, the problem with the firmware is that the firmware has both forward and reverse functionality, which is not something I want. I just want a simple one direction control. Well, I know that I can just program my Arduino to do the fancy thing, but anyways, it's just one of my project requirements. I don't want to have two direction control. I just want a single direction control. And then again, I do some googling, and then I found this repo again. This is actually the SimonK firmware, which is actually quite popular in RC world. I just learned about that, and in the repo I found this file. It says this guy over here, which is AfroESC, and I read the file because the reason being is because on the BlueESC they said that they use AfroESC, so I thought, well, why not just use Afro firmware instead. And reading this file, I noticed that all of the pin mapping is different than the BlueESC, because the BlueESC wire their MOSFET gate differently. And after reading it, like for example here, all of the PMOS is being wired to port B of the chip, and all of the NMOS is, well, it is somewhere. Okay, so this is all of the NMOS, which is on port D. And then I made a few modifications on the circuit and burn it using this tool. This is also a tool that I found on Google. I will post all of the links in the description, and then this is the Arduino sketch that I use to test the ESC. Okay, so the Arduino on the table right now is just act as a servo tester, and there is nothing special about it. It's just the duty cycle. I mean the pulse period of the servo signal. And by the way, I flashed the firmware using this USBasp tool. And yeah, so the circuit now works, and now as you can see, I am powering it using my power bank, and you can see the power consumption right now is pretty much 0 because the motor is not running yet. And now if I turn on the potentiometer, you can see that the motor is now beeping, and you can also see the signal on the scope. And the reason why it is beeping is because the motor is having difficulty to start itself up. Now I have to give it a little bit of push so that it can start. And you can also see the LED start to blink as well. So you notice, look at the red LED. If I start to spin this, you will notice that the red LED will turn itself off. Anyways, so this is the signal. So the yellow trace is the signal on this phase A of the motors, and the blue signal is basically the NFET gate signal, and I use it just to give me a good trigger signal for the oscilloscope. And now this is with certain duty cycle, I guess. And now if I increase the duty cycle to 100%, you can see that this is the signal without any modulation. And the motor is now spinning quite fast. And now if I just reduce the duty cycle, reduce the potentiometer, you will notice that the motor speed is decreasing. And if I increase the speed again, you can hear that the motor is actually speeding up. And now this is actually operating in sensorless mode. I am not using any sensor here. This is just a motor from a hard disk. And now you can also see if I start to load the motor up, the commutation frequency reduces, which is good. And this has so much more torque than the one that was done by microchip. I'm not too sure why. I'm pretty sure I've done something wrong. I cannot replicate it. But yeah, so anyway, so this SimonK firmware works quite nicely. And yeah, I am quite pleased with it. And now the only problem that I'm facing right now is to get it started by itself. And right now I'm guessing the reason why it has the difficulty to starting up is because the voltage that I'm feeding in is actually 5 volts, which is from my power bank. You can see the power consumption there, which is not that high. But anyway, so now since my Farnell order just arrived today, I will convert all of this circuit to use MOSFET instead, because all of these are MOSFETs basically. And right now I'm just using BJT transistors because I got it for free from the uni. And well, this is the transistor. It's just a simple TIP31A and TIP32, I guess. So yeah, in conclusion, it is actually quite easy to make your own BLDC. All you need is just to buy the 80MHz chip and the USBasp chip. I mean this module to program to flash the chip, and then this tool which can flash the right firmware, and maybe one arduino just to debug stuff. And yeah, that's all. It is actually quite easy to make your own ESC because all of the hard work already done for you. So yeah, thank you for watching, and hopefully this video will inspire you to make your own ESC.